Alrighty y'all, today we'll be installing a 60 amp circuit for a Tesla universal wall charger. My initial disclaimer is that I'm not an electrician, and this video is for entertainment purposes only. If you do decide to tackle a project like this with or without professional help, realize that electricity is extremely dangerous and mistakes can often cost you your life. I recently got a Tesla and wanted to have the ability to charge it as quickly as possible at home. This universal wall charger allows you to continuously charge at 48 amps on a 60 amp circuit with a power output of 11.5 kilowatts. I've done heavy research on the appropriate wires for this installation and have determined that there are two feasible options. You can either run 4-2 Romex or 6-gauge THHN stranded copper inside of conduit with a 10-gauge THHN stranded copper ground. If you're going to be exiting the building, you have to run that THHN that is also rated as THWN-2, which can be used in wet or dry locations. Note that most THHN you buy at large hardware stores are dual rated. Also be aware that it's against most electrical codes to run Romex in conduit outside of a building. In addition to being against code, it's also a pain in the butt to run Romex inside of conduit. Speaking of conduit, the ID of 3/4 of an inch scheduled 40 PVC is 824 thousandths, and based on conduit fill tables, you can run up to 4 THHN 6-gauge wires in 3/4 inch scheduled 40 PVC. Because I already had some on hand, I chose to construct my interior run out of 1-inch conduit. I'll be coming out of the top of my subpanel and making a short run to the front-facing wall of my garage. Later we'll be exiting the building and mounting the charger on the external wall. Note that during this job, my subpanel has been disconnected from my main panel for safety. I used my manual hole puncher here to put the appropriate size hole in the top of my box for 1-inch conduit. I was able to use one of the 1/2 of an inch knockouts to pass through the main threaded section of the tool. I threaded my two number 6 THWN-2 wires through the conduit elbow and then ran my ground wire to the ground terminal on my subpanel, which, because it's a subpanel, is separate from the neutral bar. Using a torque screwdriver, I tightened the number 10 THWN-2 ground to 2.8 Newton meters or 25 inch-pounds per the callout sticker next to the ground bar on the panel. The 60 amp breaker documentation calls out 45 inch-pounds. From what I understand, it's better to reach these torque values with the breaker outside of the panel so as not to put undue stress on the panel's blades. Before continuing this run, I decided to drill my hole in the exterior of the garage and into the inside wall so that I can measure my conduit appropriately. Instead of renting a hammer drill, I made the call to order this cheap 7.5 amp WorkPro drill. You never know when you'll need to drill another hole, and this drill was dirt cheap on Amazon. I'll drop an affiliate link below for those of you who are interested. The core bits I ordered were also very cost effective, and the one I used had an OD of 1.6 inches. For this light duty task, they did a fantastic job. I'll be utilizing one of the lower rear entry points of the universal wall charger, which is about 1 inch offset to the center line of the charger. After measuring and marking the appropriate drill location of my bricks about 48 inches up off the ground, I backed up my truck and plugged in the drill. It only took a few minutes to get through the brick, and I used the same coring bit to drill through the wooden backer as well. On the inside, I measured out the hole in the drywall about 1/2 of an inch higher so that any moisture built up around this installation would drain towards the exterior. I'm not sure if this really matters, but it felt like a good idea at the time. If I remember correctly, I just used a standard 1 1/2 of an inch hole saw to get through the drywall. To go through the wall, I'll be necking down to 3/4 of an inch conduit since the strain relief of 3/4 of an inch will fit in the 1.6 inch hole I just put in the brick, and the 1 inch strain relief will not. In order to get the reducer to fit through the drywall hole, I took it over to my 2x72 belt grinder and knocked off the points after gluing it up to the 90-degree LB conduit body. With the location of the LB conduit body now known, I can cut my last piece of conduit for the interior run. In order to appropriately determine the length of the 3/4 of an inch conduit that I'll be running through the wall, we'll need to open up the universal wall charger and get its configuration going. It came in pretty nice packaging and with a basic set of instructions. First thing I did was drill my 3/16 of an inch holes in their designated indents. These holes will be used for mounting the universal wall charger to my brick. I then used this little step drill I picked up in the rear left location to drill a hole large enough for my 3/4 of an inch conduit strain relief box adapter. I took my time here and tested the fitting multiple times so as not to over enlarge this hole. With a 3/4 of an inch box fitting installed, I was able to get a good measurement on how long of a piece of conduit section I needed. Now at this point, I had planned on spraying some expanding spray foam around the 3/4 of an inch conduit, but forgot to do so. I'm not even sure how well this would have gone, considering that the annulus between the conduit and the brick is extremely tight. I was able to get some PVC adhesive around the joint and push the connector up onto the conduit that was going through the wall and into the back of my LB box. With some 3/16 masonry anchors, I attached a universal wall charger to the brick. Next up, I pushed the 3 wires through the conduit and cut them to length. The wiring is super simple. Each of the 6-gauge leads go into their designated L1 and L2 locations in the box. Being a 240-volt charger, they're both hots, so you can put them in either port. The ground goes all the way to the left of the box. The Tesla charger comes with its own bit, and I use my screwdriver torque wrench to install them at 50 inch-pounds per the UWC manual. For good measure, I applied some silicone around the edges and then installed the faceplate on the charger. Setting up the charger was super simple. All you need to do is scan the QR code sticker that comes with your device, which will prompt a Bluetooth connection to the universal wall charger on your phone. This sticker should be applied to your 60 amp breaker and the panel for future setup. The charger will then update its firmware. With the update complete, you'll be prompted to connect the universal wall charger to your home Wi-Fi. With all that done, it's time for the moment of truth. I plugged in my truck, jumped into the cab, and was satisfied to see it charging at around 11 to 12 kilowatts, pulling 48 amps. And that's that. This charger has been working great for me over the past few weeks in multiple weather conditions. I hope you all found value in this video, and if you did, please consider subscribing to the channel. If there's anything else y'all want to see related to charging or the Cybertruck, please let me know in the comment section. Until the next time, this is Redbeard Engineered, signing off.